just going to do one more example so we can learn how to solve some of these same problems by graphing instead of by using the algebraic methods that we've been using. Basically, you take each side of your equation and you set them, like you make them into functions. So instructions, we're going to separate each side of our equation into two different functions. And then when you put it in your calculator, you'll have y1 equals one side of it and y2 equals the other side of it. Then what you do is graph, and the solution will be where they intersect. Okay, let's try a problem together. Here's our example. E to the x equals 4. Now we could of course solve this using any of the methods we've learned today. Taking the natural log of both sides is a fabulous way of solving this. Natural log e to the x equals natural log 4. Move the x out here so we have x natural log e equals natural log 4. The reason natural log is so awesome is that that cancels out with the e. So x just equals your natural log of 4, and you just plug that in your calculator to get your answer. Okay, but that's not by graphing. We're going to solve by graphing, just because it's good to know how to do things more than one way. Okay, so to solve by graphing, we're going to then turn this into two different functions. So one function equals e to the x, and the other function equals 4. Now I'm going to take my graphing calculator, go to y equals, clear out what's in there, type in e to the x power for one of my functions, and type in 4 for my other function. Okay. The way that I typed e to the x in is I used the second button with the divide symbol to get e, but you can also use natural log, and then I had to use the caret. You can also use natural log that just already has the e to the x, and then just type, then just type in the x, and you don't have to use the caret. If you do that one, either way works. So now I graph both of those. So there's our exponential function, e to the x, and here's our constant function, y equals 4. We want to figure out that solution right there where they intersect. So we hit second, calculate. I want to find the intersection point, so I'm going to push the number 5 for intersect. Then it just asks me to make sure I've got my cursor on each of the graphs. So yep, there's one of them, and yep, there's the other one. And now it allows me to just make a guess as to where that intersection point is. You don't even have to move the cursor, you can just push enter again. Should jump right to our point, which, see how the x value is 1.86294 and y equals 4. The answer is the x value. You're solving for x. The reason that y equals 4 is because that was part of our problem, that y equals 4. So the y value in this answer doesn't even make any difference because it was just part of the problem. So the x answer according to our calculator was 1.386. I'm just going to round it to 1.39. So now let's check and see if we get the same answer doing that one algebraically. So we could go quit out of here, natural log of 4, enter. Well, what do you know? Same exact answer. Anytime you do anything on your calculators, please, please, please sketch it so that I can see what you've done. So that point right there would be 1.39, right? So sketch it out so that I know that you did it the way I wanted you to, and that's your proof.